All right, problem 6. Solutions to the differential equation dy dx equals xy cubed also satisfy the second derivative equals x cubed times the quantity 1 plus 3x squared y squared. We're going to let fy equals f of x be a particular solution to that differential equation with f of 1 equaling f of 2. Okay, part A. They ask us to write an equation for the line tangent to the graph of y equals f of x at x equals 1. So we want an equation of a tangent line. So I know I'm going to start with y equals mx plus b. Okay, first thing I want to do is find the slope, and then I know that that is the derivative, and dy dx is also a derivative. So I would like to find the derivative at x equals 1. So if I find dy dx at 1, I'm going to actually do xy cubed. Well, fortunately, they told me when x was 1, y was equal to 2. So it's going to be 1 times 2 cubed, and that equals 8. So we just found my m. All right, we know that the x value is 1 and the y value is 2. So if I just finish this up here, I'm going to get 2 equals 8 times 1 plus b. So I'll get 2 equals 8 plus b. If I subtract 8, I'll get b equals negative 6. So the equation of my tangent line is going to be y equals 8x minus 6. All right, that answer was worth 2 points. I got 1 point for finding the derivative equaling 8, and then I got 1 point for the tangent line. All right, onward to part B. Okay, use the equation of the tangent line from part A to approximate f of 1.1. So I'm just going to do that part first. So similar to what we did on a multiple choice problem earlier, I basically am just going to use x equals 1.1 as my x value. So I'm going to put y equals 8 times 1.1. Oh, excuse me, it'll be minus 6. So I don't get a calculator, so I'm going to do 1.1 times 8. That will give me 8.8. So it's going to be 8.8 minus 6, and that will equal 2.8. So that will be my answer for that one. And then the second part of the problem, it says, given that f of x is greater than 0 for any number between 1 and 1.1, is the approximation for f of 1.1 greater than or less than the actual value? And explain your reason. Okay, what I'm going to do here is if I were to put, I'm going to take a look at the second derivative because I'm guessing there's a reason why they gave me the second derivative. I know that at x equals 1, if I were to plug 1 in, the point 1 I'll plug in, if I'm finding the second derivative, my y value is 2, so I'd get 2 cubed times 1 plus 3 times 1 squared times 2 squared. I'm not going to bother figuring that out, but hopefully you can see that that is going to be a positive answer. So since my second derivative is positive, I know that my graph is going to be concave up. And so if I just kind of think about this a second, if my graph is concave up, then that's what a concave up graph looks like. Then let's say this is a point 1.1 right here. If I drew the tangent line, notice that the tangent line is going to be underneath the curve. And since the tangent line is underneath the curve, that value that I'm estimating is right here, and you'll notice it's underneath the actual value. So it's less than the actual value. So what I would say, it said, is the approximation for f of 1.1 greater than or less than? I'm just going to say the approximation is less than f of 1.1. And the reason that I'll say it's less than is because the tangent line lies under the actual curve. And you might have a different explanation, which is fine, but that's what we should get. So that part was worth 2 points. If you got 2.8, you got a point. If you were able to say that the approximation was less than and you had a good reason for it, then that was worth another point. Okay, part C. Part C, find the particular solution. So hopefully the second you see that particular solution, we know that we are going to somehow have to cross multiply. We just need to decide what are we going to cross multiply with. So you have to look for an equation that you can cross multiply, which is going to be this equation right here. We're not going to use d squared. We're just going to use the normal one. So dy dx, and remember this is a big point value on this one, xy cubed. All right, we want to cross multiply, so I'll put a 1 underneath. So I'm going to get 1 dy is equal to x y cubed dx. Now I have to have my variables on the same side. So I'm going to divide both sides by y cubed. So I'm going to get dy over y cubed is equal to x dx. And now that I have my variables on the proper sides, I'm going to draw integrals to show that I'm now going to take the integral. All right, the left side, I do not like that y being down there, so I'm going to make it into y to the negative 3 dy. And then on the right side, I'm just going to leave it how it is. All right, now the integral of the left side, we're going to add 1 to our integral, so we'll get y to the negative 2. And then we always put the reciprocal on the outside. So negative 1/2 y to the negative 2 equals the integral of x will be 1/2 x squared plus c. All right, and then I just like rewriting this so that I don't have a negative power because most people don't like working with negative powers. So this is going to be 1 over 2y squared is equal to 1/2 x squared plus c. Now it did say to find a particular solution, so it said y equals. Before I do anything with fractions and doing stuff like that, I usually like to find the c first because I find that just to be easier. So we are going to, this is my x, this is my y. I'm going to go ahead and plug in what I know. So I'm going to have negative 1 over 2. Y is 2. So negative 1 over 2 times 2 squared equals 1/2 times x squared plus c. So now I'm going to have negative 1 over 8 equals 1/2 plus c. I'll subtract 1/2 from both sides. If I get a common denominator, which would be 8, this will be negative 1/8 and negative 4/8. That means that c will equal negative 5/8. All right, so if I go to rewrite this, I'm going to get negative 1 over 2y squared is equal to 1/2 x squared minus 5/8. Okay, here comes kind of the tricky part. There's lots of different ways to work this problem. I think I am going to, which way do I want to work this? I think I'm going to clear the fraction. The way that I'm going to clear the fractions is the common denominator of all these would be 8. So I'm just going to multiply everything by an 8 and just hopefully this will make it better. Let's see. So if I multiply this one by 8, it's going to be 4 over y squared. If I multiply this one by 8, it's going to be 4x squared. And if I multiply this one by 8, it will be minus 5. So hopefully that made it look a little better. Okay, if we're going to solve for y, I'm going to make the right side a fraction, and I'm going to cross multiply. So I'm going to get y squared times 4x squared minus 5 equals 4. And remember, my goal is to solve for y, so I'm going to divide by 4x squared minus 5 over on both sides. And then I'm going to get y squared equals 4 over 4x squared minus 5. And then I would like it to say y equals, so I'm going to get y equals the square root of 4 over 4x squared minus 5. And I noticed that my actual answer was a positive, so I would like the positive square root. So that's what I will put as my answer. So let's see how many points that was worth. Hopefully we got a lot there. Okay, number 1, if you separated your variables, which I did, we got a point. Okay, number 2, if you took the correct antiderivative right here, so if you did this, you got this, and you got that, you get a point. If you put plus c, just for putting plus c, you got a point. If you found c, you get a point. And then if you went this whole extra step, you'll just get 1 point. So notice, if you can't, once you find your c, if you can't get all the way through, don't worry too much because it was only worth a point. Everything else was worth most of the general points. So I think that's it. If you did not separate your variables, you got 0. So make sure you're separating those variables.